Hey everyone, welcome to the Pre-algebra 5.2 video. We're talking about adding and subtracting like fractions, okay? So, first of all, what is a like fraction? Well, like means what? Same denominator, right? Same denominator, okay? So, 4/5 and 3/5 are like fractions because they have the same denominator. Okay, and so we remember, okay, so a lot of this will probably be reviewed, that if I was to add those two fractions, well, they have the same denominator, so therefore my answer is also going to have a denominator of 5. But what do I do to the 4 and the 3? I just add them. 4 plus 3 is 7. So I'm left with 7/5 as my answer. And in algebra and pre-algebra, we actually like improper fractions. The big reason is we're going to get into slope later on, and with slope you can't have a mixed number. So 7/5 is acceptable. If you really wanted to write it as a mixed number, you could say, well, let's see, 7 divided by 5, that would give me 1 and 2/5 as well. But I actually prefer this way, unless we're talking about baking, right? Because, like, 1.5 cups of flour makes a lot more sense than 3/2 of a cup of flour, okay? Or, talking about measurement, 5 1/3, feet makes a lot more sense than 16/3 of a foot. I really don't like that. That makes a little more sense. But really, baking and any kind of measurement is really the only place I like mixed numbers. Everywhere else, I really prefer improper fractions. So that's, it's pretty easy. We can do that pretty well. But what if I had -4/7? And I said, let's take away from that 2/7. Well, let's see. Well, it's a subtraction problem. Okay, so the first thing I should probably notice, though, is I have common denominators, right? They're both 7. So in addition or subtraction of fractions, if both parts have the same denominator, then my answer will also have that same denominator of, in this case, 7. So the top would be the -4 minus the 2. Well, -4 minus 2 we know is -6. And so it's really that easy because our answer is -6/7. Okay, well, what about, 4/9 minus 7/9? How about that? Well, let's see. We know that same denominators, both here and here, right there and there, so I'm going to have a 9. 4 minus 7. Well, let's see, 4 minus 7 give me -3/9, right? And I'd be done. Wrong, because I can do what? Simplify the fraction. Okay, so let's see, I can take a 3 out of both of those, so -3 divided by 3 is a 1. 9 divided by 3 is a 3, so I'm really left with, can't forget the -1/3. Also can be written like this. Either way is totally fine. Alright, so why don't you pause the video, and I want you to go ahead and try this problem. Take a second, give it a good stab, play it when you're done. Alright, so hopefully you recognize, in order to add these, I need to make them into improper fractions. Okay, so let's see, this one would become, well, 9 times 5 is 45, plus another 5, that would give you 50/9, plus 2 times 9, 18, plus a 7 would be 25/9. And let's see, common denominators, awesome. The answer is going to have a denominator of 9 until we simplify it, if we have to. 50 and 25 gives you 75. All right, so am I done? Well, see, I can divide both those by something, right? Well, I could divide by 3, all right? Divide by 3, or take out a 3. And let's see, 75 divided by 3 give you 25. 9 divided by 3 would be 3. And I'm fine with this as an answer, personally. But again, if you really want to do a mixed number, well, let's see. 3 goes into 25. Let's see, 8 times with 1 left over, and you keep the denominator. 8 1/3 would also work. And there you go. Alright, so I want you to pause the video, and I want you to try this one. A little more complicated, but I'm pretty confident you guys can get it done. So go ahead and try that, play it when you're done. Alright, so that's what we have. -3 2/7 plus -6 3/7. That plus negative should clue you off to what? Well, it actually means subtract. So let's rewrite. -3 2/7 minus 6 3/7. Okay, so now we've rewritten. So now we have a subtraction problem. That's fine, but it's probably best to put them in, well, let's see, improper form. So when I put these into improper form, let's see, it's a negative 3 2/7. I know that even if I change this into an improper fraction, it's still going to be negative. So for the time being, I'm just going to write that negative sign down here, and I'm going to pretend that this is positive just for a second. So 7 and 3, 21, plus a 2, right, gives you 23 over 7, and we have this negative sign there, so we know we're good. Minus, let's see, well, 6 and 7 is 42, plus a 3 give you 45, divided by 7. So, now what do we have? We have a negative 23/7 minus 45/7. Well, at least we know the denominator is going to be common denominators, right? So it's going to be a 7. And then we have negative 23 minus a 45. Well, remember, if we have a negative number we're subtracting, it's like adding the two of them. And then we'll slap on a negative sign at the end. So 3 and 5 is 8, and then we get a 6. But remember, it's a negative 23 minus a 45, so we're going to make that a negative, and we end up getting negative 68 over 7. And if we wanted to write that as a mixed number, well, I'd have to say, let's pretend it's positive for a second. 7 goes into 68 how many times? Let's see, 9, I think. Yeah, so it'd be 63 with 5 left over and a denominator of 7. 9 and 5/7 would work, but again, it's a negative 9 and 5/7 because it was a negative 68/7 there. This answer is probably my preferred. This one also works. They are the exact same, and you'd be done. All right, so I hope that last bit was pretty much review for you guys. You know, I understand if we're adding in the negatives that might complicate things. You haven't seen that yet. That's totally fine. We'll practice plenty in class. But one of the reasons we kind of talk about this is so we can do some more advanced stuff, such as simplifying variable expressions that have fractions, such as 2a over 7 plus 5a over 7. Okay, so, what do we do here? Well, let's think. The first thing we do when we have to add fractions is say, do I have common denominators? Yes, we're in luck this time, I do, right? Those are like fractions because they have the same denominator. So you know what? Even though there's variables here, my denominator is still going to be 7, okay? But then I just evaluate what's on top. 2a plus 5a, right? 2a plus 5a. Well, what is that? Well, it's like saying 2 apples added, and then you add 5 apples, so you're left with 7 apples, right? And then we remember that from before that when we have fractions that contain variables, I can still simplify them, right? Because this really means 7 times a over 7. So I have a 7 over a 7. Well, I can cancel both of those and make them 1 over 1. So really I'm left with, in the end, 1a over 1. And you know what 1 over 1 equals? It equals just plain old 1. Or I can just kind of rewrite it as 1a, which guess what? I can rewrite it as just plain a. All right? So if that's a little complex for you, I understand, but I want you to go ahead and try this. Just give it a shot. Why don't you do 3a over 20? And I want you to add to that 5a over 20. Pause the video, give that a shot, see how you do. All right, so hopefully you recognize we have common denominators here, 20 and 20, so we'll end up with a 20. And then you just evaluate the top, 3a plus 5a. Well, it's like saying 3 apples plus 5 apples gives you 8 apples, right? And you're partway done, but you need to simplify. Can you simplify even though you have a variable? Absolutely. So just look at the 8/20ths part. 8 over 20. Well, let's see. I can divide both 8 and 20 by 2 would work, but how about 4? Right? So if I divide 8 by 4, I'm going to be left with 2. Right? Divide by 4. And I still have the a. If I divide 20 by 4, I'll be left with plain old 5. So now I have a 2/5. Can't simplify that anymore. So 2a over 5 would be our final answer. All right? Give this one a shot. This will be number 7. Negative 8 over 3b. And we'll take that minus negative 2 over 3b. Pause the video, try that one, play it when you're done. Okay, so this one was supposed to be a b, it kind of looks like a 6. Okay, so what's the first thing you notice? So the first thing I noticed was I have minus a negative. What does that always mean? It means plus a positive. So I'm going to rewrite. I have negative 8 over 3b plus 2 over 3b. All right, so let's see. I now have an addition problem, don't I? And when I have an addition problem, and there's fractions, I say, well, do they have common denominators? Yeah, these do. They're both 3b, so our answer is going to have a denominator of 3b until we simplify it if we have to. So now, what's on top? Well, this negative sign is going to be applied to the 8. Okay, I almost always apply the negative to the numerator. Okay, so it's really a negative 8. Negative 8 plus 2. Well, if I'm over here at, negative 8 and I add 2, that would put me at negative 6. So now I have a negative 6 over a 3b. And I'm almost done, except that I need to simplify. Okay, well, let's see. I could divide both negative 6 and 3 by 3. All right, so negative 6 divided by positive 3 will give you a negative 2 over 3b divided by 3. Well, that just leaves you with the 3 divided by 3 is like saying 1b. Okay, and you would be done there if you wanted to, and this is what I usually do. If I have a 1b, remember, if I had like 1x, how could I write that? Just x. So the same thing applies here with this 1b. I can just rewrite that as b. And again, we have the negative 2 on top. And that would be your answer, and you'd be done. Well, you've made it to the end of another video. I look forward to talking with you in class about adding and subtracting like fractions, especially ones with variables, because they're awesome. And yeah, see you later.